we want to start a new topic right now, which is scalars and factors. Under this topic, candidates are expected to be able to distinguish between scalar and factor quantities. They are also expected to be able to give examples of scalar and factor quantities. You should be able to determine the resultant of two or more factors. And at the same time, being able to resolve factors into two perpendicular components. Under this topic, we are going to treat the following questions. Question number 1. In the diagram above, P, Q, and R are factors. Which of the following options gives the correct relationship between the factors? We are going to talk about what is a factors or what a factor quantities. Factor quantities are the quantities that have both magnitude and directions. And when we are talking in terms of magnitude, we are talking in terms of size. Directions will be in terms of angle. They have both magnitude and direction. But for scalar quantities, these are the quantities that have only magnitude but no directions. So we have this diagram here. The question says in the diagram above, it says P, Q, and R are factors, because you can see the arrow indicating the direction towards this side, the direction. We should determine which of the following options, we have the options there, that give the correct relationship between the factors. We have the option A, say P is equal to Q plus R. Option B says P is equal to Q minus R. Option C, P is equal to PQ. Option D, P plus Q plus R is equal to what? 0. The right option is option A, which is equal to P is equal to Q plus R. P is the resultant. The other two factors are the factors of the operating to give the resultant P. So, by the time we had factor Q and R together, it will give us the resultant factor P. And the right answer there is option A. Question number 2. A quantity which requires magnitude and direction to be specified is, we have option A, temperature, option B, distance, option C, displacement, option D, mass. The question says the quantity which requires magnitude and direction. That is a quantity that has both magnitude and direction. In all the options we have, which one is the best option? The answer there is displacement. Temperature is a scalar quantity. Distance is a scalar quantity. Mass is a scalar quantity. But displacement is a vector quantity that has both magnitude and direction. Question number 3. The pair of physical quantities that are scalar only are option A, volume and area, option B, moment and momentum, option C, length and displacement, option D, impulse and time. In this question, we are given those quantities in pair 2, 2. We have to determine which of those options are both scalars. Volume and area are scalar. Moment and momentum are vector. Length and displacement, length is a scalar, where displacement is vector. Impulse is a vector, while that of time is scalar. So out of all the 4 options we are having here, both volume and area are scalar. Both volume and area. And so the good options there is option A. Volume is a scalar quantity. area is a scalar quantity. We are moving to friction as a topic. Under this, candidates should be able to, number one, differentiate between static and dynamic friction. Number two, they should be able to determine the coefficient of limiting friction. Number three, they are to compare the advantages and disadvantages of friction. Then, finally, they should be able to suggest ways by which friction can be reduced. Under this, we are going to quickly consider some questions. Some involve calculations. Question number one. The question says, what is the coefficient of static friction between a load of mass? We are given a mass. The mass there is 0.75 kilogram and a horizontal surface. If the limiting frictional force is 5 Newton, and we are given the value of G to be equal to 10 meter per second square. We are looking for the coefficient, the coefficient of static friction. You remember that the frictional force is directly proportional to the reaction. If we are to take this proportional sign from here, F will be equal to, so what we are having here now, this symbol is what we call that is what we call coefficient of friction. It now depends on what we are looking for. Is it coefficient of static friction or dynamic friction? So we can make our coefficient of static friction to be a sort of the formula from here. Then we are going to have F over R. We are given mass. We are given force. We have the value of G. We are looking for this. So to calculate the coefficient of static friction, will now be equal to our force over reactions, which is going to be force divided by mg, because our reaction will be equal to the mass of the body and the acceleration due to gravity, which is equal to, we are given the value of force, that is 5 Newton. The mass is 0.75 times 10, which is equal to 5. Then 0.75 times 10 will give us 7.5. And altogether, 5 divided by 7.5 will give us 0.667. And you know that coefficient of friction, it has no unit. Why? Because what we are having on top is a force, the answer also is a force, which is measured in Newton. Newton cancel Newton, then it has to be 0.667 as the value of the static coefficient of static friction. We are going to consider question number 2. A child pulls a toy weighing 3 kg. We are having mass 3 kg along a cement floor. If our G, the value of G is 10 meters per second squared, and the coefficient of friction is equal to 0.5, the minimum force required to move the car is, we are looking for force. We are still going to the same formula is required for this question, which is equal to mg. We are given the coefficient, which is 0.5. We are given the mass, which is 3. We are given the value of G, which is 10. So altogether, we are going to have 0.5 times 30. 0.5 is half times 30 times 15 Newton. Because we are looking for force, Newton. And that's the answer for question number 2. Question number 3. If an object just begins to slide on the surface, inclined at 30 degrees to the horizontal, the coefficient of the friction is, we are given the angle of inclination to be 30 degrees to the horizontal. What will now be the coefficient of friction, which is equal to tan 30 straight away. Whenever you are told that a frictional surface is being inclined at an angle to the horizontal and the angle is 30 degrees, just go straight away. The coefficient of friction is tan 30, and tan 30 is 1 over root 3. 1 over root 3, and that's the answer. Question number 4. A bead traveling on a straight wire is brought to rest at 0.2 meter by friction. If the mass of the bead is 0.01 kilogram and the coefficient of friction between the bead and the wire is 0.1, determine the work done by the friction. We are given the mass of the bead. The mass is equal to 0.01 kilogram. We are also given the coefficient of friction, which is equal to 0.1. Because we have to calculate the frictional force, which is the work done. The question is to determine the work done by the friction. And the work done will be equal to force times distance. But first here, we do a